and we'll touch on some of the advanced signaling that's being done. Now, I want to tell you right up front, the disclaimer here is that I have a problem with electricity. And I can barely plug in the television set. So when I thought about putting a signal system on a layout, it had to be non-operating. So, but fortunately, that was many years ago, and as electronics have developed and everything, some of you may already operate some pretty sophisticated electronic systems on a layout, so, or a club layout or whatever, that I've seen some beautiful applications of it. Okay, Lee. These are the basic elements of any prototype railroad signal system, and some of this information I'm going to share with you comes from my experience of about 2.5 years as chief engineer of signals for CSX, and particularly at the point of time where we were really starting to develop our detailed plans about switching over to positive train control and so on. So obviously, if you think back in the 1800s when you had block operators, they might have a system of crude balls that they could raise. That's where the term highball came from. If you got a highball, it wasn't a drink. It was usually a green ball that went by rope to the top of a pole, and the train would come along looking for a highball. If he had the highball, away he'd go. So that's where that term came from. But signal systems are a method to convey authority for train movements. It's also, it morphed into a way of controlling routes on trains. So as train control, or TC, developed, you could remotely control switches and so on. Warning systems and the hardware, the wayside housing and so on that went with that. One of the things that not many people realize, the railroad, and I'm speaking from CSX's perspective, they only pay a small percentage of the installation of a crossing warning system. It's not CSX's or Norfolk Southern's decision as to whether a warning system is installed at a particular crossing. That is strictly under the purview of the state DOT. And they do studies, traffic studies, and train traffic, automobile traffic, all the other applications, and they direct to the railroads where these installations are going to be. So almost 95% of the cost of an installation of a warning system is borne by your tax dollars. And what the railroad's part of the bargain is, once that's installed, typically using railroad unionized personnel, once that's installed, the railroad picks up the ongoing maintenance costs. And in the case of maintenance to the pavement over a crossing, that remains the purview of the local governmental authority that maintains the road. So if you have a rough crossing, don't blame the railroad. Talk to your local government authority about that. Next. The track circuit really is largely unchanged from when it was first invented back in the 1800s. You have a battery that feeds power to one rail. When a set of wheels comes in contact with the rails, it shunts the power, trips a relay, and everything starts to happen. if this happened to be most track circuits today have been converted over to ultrasonic track circuits, so that there's a high frequency signal going through the rail, and a pair of rolling wheels disturbs that high frequency signal. That's picked up by solid state components in the signal bungalow, and things start to happen from that. So, but they still require power to the track, so there is a battery feed going to the track. Okay. Insulated joints divide the various track circuits on the railroad. It could be an insulated joint, mostly for the signal system, which is conveying the authority for movement to the train, but in some cases that might apply to a warning system. So you can actually buy insulated joints in different scales. I had some O-scale insulated joints, and glue those on the side of your model and replicate insulated joints around your layout. Okay?
David, that's with some sort of epoxy resin and plastics? Is that how they?
Yeah, it's these, usually an insulated rail section is made up at a plant and comes out to the field as a piece of rail with an insulated joint all molded on there. Obviously these steel bolts that are holding the rail together need to be insulated from each other, so the insulated joint itself has non-conducting components related to it that anywhere it would cause a circuit to jump the rail, you've got insulation in place to prevent that from happening. Okay. The relay case is important because whether it's a conventional relay system with the magnetic type relays or it's a solid state system, you got to have a box for all that to reside in. So, and to allow access to the maintenance personnel as well. So if you've got a wayside signal, you need a relay case. Okay. Just to show you what's inside the case, this is the typical of the old style track circuit. So if you're modeling the 1950s or whatever, your case, your bungalow has to be big enough to house a whole row of these particular relays. And sometimes you could, if you have one of those in your area and you're standing next to it, you can hear them clicking and so on inside. Well, that's all these this magnetic relay. Here's the the coils and all, and as that has a preset tension on it that's set at the bench by personnel that certify these relays. And then, of course, there's the contacts that can be feeding the circuits out to the field. Okay. So, block signals were some of the earliest forms of control, and it predated the track circuit, and that's where you had personnel, a tower or something like that would control a specific block. And the first CTC went in service in about 1927. And I wanted to point out one thing that's a misuse of a term. A lot of people I've heard will say, well, do you have CTC on this track? And it's a system that was not Union Switch and Swindle, I call it. CTC is the trademark of Union Switch and Signal. So if you have a GRS system, General Railway Signals, it's a TC system, a traffic control system. So
I didn't know that either.
it's sort of like people.
Copy machine.
It's like modelers talking about, well, I put stirrups on my box car. There are no stirrups on any freight car. There's sill steps, and that's one of the most misused terms. And even some of the model producers call their sill steps, call them stirrups. Well, there are no stirrups. Stirrups go on the end of the saddle.
And there's no outside brace boxcar, there's single sheath boxcars.
Right. And anyway, you could do a whole clinic on nomenclature. Don't forget in dark territory, so if you're not modeling a system that has TC on it, you're still gonna have certain wayside details because you're gonna have warning systems that are on that, or you may have defect detectors and so on. We'll get into that in a minute. Okay. Here's an example of a simple block system that happened to be a Central of Georgia old photo, but this was a time release, and this is part of the circuit controller. So if the switch opened one way or the other, it would cause the indication to change. And the time release would not allow that switch to be thrown unless the exact time had run. And that depends on that amount of time. Let's say a dispatcher had a train, he intended to run and make an opposing meet there. You couldn't change that position of that switch without running the time, they call it. So some modelers that know signal systems, that might be a feature of your operating session. You pull up into a situation that requires a time release, and so you have to sit there with your train until that scale time or whatever runs. And the reason for that is to allow, depending on the allowable speed on that line, allow a train an opposing train to be able to stop short of the other train. So, or if the switch has been changed or whatever happened, the operation requires. So I'm not gonna get into that any deeper, but this component, these are some of the components that you might find around a simple block signal. Okay. Intermediate signals would be between control points. A control point being where you'd have a switch, then you could use it, go to a different route. But let's say that distance to the next siding is 10 miles. Well, you're going to have intermediate signals in there. One of the reasons being about as far as technology, even today's technology, will allow you to shoot a track circuit internally in the rail is somewhere in the neighborhood of 15,000 feet. And at that point, the signal starts getting too weak to be effective from a safety standpoint. So you're going to have intermediate locations where you're going to have a break in the track circuit. Now, get into the positive train control side of it, where you got the satellites involved, communicating with the movement of the train. That becomes a little different situation, but not sure what the FRA decided on all this over the last 10 years or so. In some cases, they were not going to permit, even though you had positive train control, and the satellite is watching the conflicts between trains, they were still gonna require wayside signals. And so, it's almost like this wayside signal system, you could envision that being totally redundant and unnecessary. But for whatever reason, they've decided not to retire the wayside side of it. So, this is a CSX permissive signal with the P plate on there, meaning if you got a red, you can proceed at restricted speed beyond that, but without stopping, but you gotta be ready to stop within half of the range of vision. This is GRS, typically the color light system like that is a GRS example. This is probably also a GRS example, okay? And in traffic control, where it's centralized, using the Union Switch and Signal unit, the train dispatcher in the old system had a code line that went out, and let's say they wanted to throw a switch remotely, several hundred miles away. That code signal would travel over a pole line. There'd be a code unit here at the station. It would be interpreted in the field, and the signal and switch position could be changed that way. And of course, CSX went through a period where we had radio controlled code signals, so the pole line could be eliminated in terms of having that signal physically go through the pole line. That was all done by radio. Okay. This is an example of a controlled siding. What you should look for, and I tried to represent that to some extent on this module here. So the components there you're looking at, of course, your wayside signal mounted on a foundation with a special base. You've got your bungalow that houses the switch gear inside. Another bungalow for, again, track circuits. You've got commercial power coming in to feed. You've got the warning system involved. So here's all these details around that you can model without having to worry about wiring all that stuff up. And so that's what's represented here. The way of improving the appearance of your model, doing it in a static fashion rather than trying to wire it all up and make it function. Okay.
Can we go back? Is there a second bungalow on the left side beyond that one?
Could have been.
Because it looks like that one's in line with the switch machine, and then back by the other signal. Is that not a signal?
To your right there. Oh.
Yeah, right there.
Yeah, that's that's a signal that's governing the move down through the siding here.
Yeah.
And the way these aspects are set up, this you can run in this siding under signal indication. Okay. Here's some more details, and I happened to catch one that caught the transition from going from the Union Switch and Signal searchlight system to the new positive train control. I've heard people call that the Darth Vader type of signal. If you were to pull out the signal standard for CSX, the drawing that has that on there, you'd find my name signed down there because I was the guy that changed the standard to the Darth Vader type signal heads
For the
So
searchlight.
you're to blame.
I'm the guy to blame, but I'm telling you, they're a lot easier to see when you're on the locomotive.
Searchlights were pretty standard on the L&N.
Yeah,
Two questions. One, was L&N mostly USNS or were there GRS installations?
L&N was mostly USNS and NC was GRS. There's some variations of it. L&N made some installations of GRS equipment and so on.
And the other question is, I've seen on CSX and not many of the other railroads using like a white PVC pipes coming up with like a lock cap on it at some of the interlockings and crossings. Any idea what that is for?
With a locked cap on top of it?
Yeah, I think so. Yeah, I mean, they've got their white PVC pipes up about this high, and then they got orange. A lot of them have orange reflective tape on them. And
Okay.
They got like a handle to pull the cap off of it.
Are you,
I've seen NS use them for like bridge markers, where so no one walks. But at CSX, I've seen them at a lot of signaling.
well, a lot of CS, well, I won't say a lot, but quite a number of miles of CSX has a fiber optic cable laid on the right of way. And those, what you're describing sounds like one of those access points for fiber optic. So that was always one thing. If you had a derailment that plowed up the ground, if you cut the fiber optic cable, they got real upset. The old CSX system using radio code, remember that little diagram I showed where the signal was going out via radio? You would find the pole with an antenna at the end of the siding. And now with positive train control, I guess you find a satellite dish on the component. Okay. There's a colored light dwarf signal on CSX. This is a searchlight style, and I'll pass. Let me pass some of these show and tells around. Here's the searchlight type dwarf signal.
You got the oscilloscope version there somewhere?
Here's a
Maybe not,
don't. Here's a searchlight head, I believe, and I like this one that BMLI or whoever it was put out years ago, but that's typical of the L&N indication that could be displayed going into a siding that was not signal. So if the switch was lined for you to go into a non-signal siding, you get a red over lunar. So and if you look in the operating rule books, you'll see all these various aspects described.
I'm on the Pensy, so it's going to be positional.
And there's a base for a mast. And here's some examples of the 3D, not 3D, but etched versions.
So David, do these showcase miniatures have the LED in them, or do you have to add the LED yourself?
I think you can order them with the LED in them. Either way. And there's a set of castings for the battery wave. This is a good close-up of a power switch machine. In my case, I've got one on the module there, and that's that one looks to be a Union Switch and Signal case. GRS also made cases, And I believe that's a USNS,
That's a good look at.
power switch machine on there.
Yeah, out of Alabama, it's coming.
Power
Yeah.
switches, by the way,
Use some
have
of their
to,
stuff for, like telephone poles and
uh,
different things. They make
function,
good stuff.
you have to put the signal maintainer has to go back and put in a 1/4-inch shim periodically and close the points against that 1/4-inch shim, and the signal has to turn red. So you can't gap a power. The power switch circuitry is made so that if it gaps open, it'll stop the train. If you didn't have that, you could get a wheel that would catch that gap and go the wrong way. This is typical of the B&O color position light dwarf signals. And I think I've got another one that has the high switch, or the high signal for CPL, color position light. The B&O was about the only railroad in the country that used color position light. The Pennsy and N&W used position light signals, but not necessarily colored. So,
Is that a lunar light right down on the rock at the bottom of the color position?
you mean this one?
No,
Or this
right
one?
there.
Yeah, that again. If you looked in the CSX rule book, that could display, say, a clear over a lunar, and which has a certain meaning. A CPL system, the advantage to that was it would show a lot more indications than the simple red, yellow, green lunar. Okay. So what's inside those houses? This is a house that's full of those old mechanical relays, electromechanical relays. Some of the components in here are solid state. There's your bank of batteries that are powering the equipment and the track circuit. And some of these are set up so that if the commercial power goes out, then they switch over to battery power. And obviously, you would want that if you have a warning system and there's a lightning storm nearby and knocks out the commercial power to it. You still want the warning system to function. And all of us always assume when we're coming up to a crossing that equipment is working. And it is designed to be to military fail-safe standards. So there's about this many decimal points in the reliability of that assure that a warning system is working adequately. Okay?
But you still should look both ways.
Still
Look both ways, right?
Yeah, you need to be looking. This is the USNS switch machine. And there again, I've got one on the training module here, okay? All right, in advanced train control setups or positive train control now, dark territory and so on. These are some of the elements that you need to include if you're doing your modeling, okay? For all operations, I like the modeling of pole lines particularly. Now, of course, they're mostly disappearing from all railroads. You still are going to have some situations where you need about 6 spans of pole length to get commercial power back into an installation. and even those are being replaced to the extent possible where they would run when they install a new warning system, they try to feed that power underground. But the pole lines are an interesting challenge. And I brought some of the components. Some of you may know Rick Rideout in Evansville that produces all the Rick's products. But these are really being located in Evansville. A lot of his material is L&N themed, and it has a wonderful L&N layout. I've never seen it, I've just heard about it, but doesn't show it off publicly. But you can take the Rick's telephone poles, and if you're lucky enough to find some of the early ones he made that had the green or clear molded plastic on the cross arms, grab them. He doesn't make them anymore. And if you look on here where I've got green cross arms, some of them I painted with a little Tamiya paintbrush, and others are some of his molded green. And I'd kill to get another bag of them, the molded green. But this company, again, you can buy this Easy line in about 4 different colors, and they even give you that greenish look, you know, the copper clad. And one of the things about Easy line, this is an Easy line set. I broke one of the cross arms somewhere in the transit. But here's what's neat about Easy line. So if you really want to enhance a model scene, and maybe you don't want to put a string pole line all the way around your layout, but you want to have it enhanced in some town scenes or whatever,
That's cool.
It really is an effective product to use. And I've had this module laying around for a long time, and some of those wires have been there for over 10 years, so it hadn't really deteriorated. So again, I bought another roll of it, expecting my old roll to be kind of brittle or something, which it turned out it wasn't. But Showcase Miniatures has that in their catalog and stuff. So it's really, even if you have only 3 or 4 sections strung up like that, it's an eye catcher to me. Commercial power feeds, I didn't draw one here. Maybe this looks a little bit like that, but you can have a drop from your pole line, because pole line may be carrying your commercial power along with the rest of the items. So you can drop that to your relay cases or whatever. Let's see. Wayside telephones. Telephone needs a message line drop, which I didn't model on this, but you'd have wires drop into that. So another function of probably a pair of wires on your pole line. Your warning systems and defect detectors. On this module, I've got a hot box detector. You would never put one in a situation around a switch like that. They would be out on a single track somewhere. CSX used to be spaced about 20 miles apart. That's being brought down to 10 miles apart. Norfolk Southern was a little ahead of CSX in that department, but that's about what's been determined through testing, that if you've got them about 10 miles apart, you'll catch a roller bearing going to in time before it goes to a catastrophic failure.
So if they had a bad roller bearing, do they fix it at the next division point or something like that, or they don't stop the train to do that, do they?
Yeah, if they get a defect, indication that they got a hot bearing. The crew will go back, check it. Sometimes they use a temple stick and make a mark on the bearing, and if it melts a temple stick, they know it can't be moved. They'll set it out at a remote siding.
Next to the
And
old
then
sign.
the car department has to come out and change the wheels on it. Some of these latest detection systems they have, you'll see the trains going through a little shed, and big light comes on when the train goes through there, and it's not only is it doing all of the typical measurements, it's also shooting a sound around a wheel, looking for a crack in a wheel.
Wow.
It's also using sound for flat spot in the wheel, and you know, there's a lot more applications of sophisticated inspection going on than when I retired. Okay. All right, just on the pole lines, there were usually two code wires going from the train dispatcher out. You had what was called vital circuits, which one signal has to talk to the next signal in line, and vice versa. So there's a dedicated set of wires on a pole line going from signal to signal to signal, and that has to go back and forth. Any of those lines are cut, obviously you get a red. The relay system is designed to fail safe. You have power transmission, I mentioned that already, in the communications. And prior, in the early 1900s, you would have a Western Union function on there in the case that we just got some records donated to us about the Western Union line survey back in 1910, I think between Mobile and New Orleans, something like that. And Western Union had a pole line, L&N had a pole line going out through the swamp, and there was a lot of back and forth contractually between the railroads and Western Union, really all over the country. Pole line spacing usually 150 feet apart. The NC and St. L, you'll see some of the old pictures where they actually painted, they measured, they set their pole line spacing according to car lengths. And so you'll see milepost 20, let's say, you'll see a 20, and underneath that it might be 15. So there would be 15 car lengths, you know, of distance. So railroads had their own standards, obviously, for that. The types of wire, the copper clad was what turned green in color on the outside, but it had a steel inside. And a lot of these wireline thieves didn't realize, they thought they were getting solid copper wire, and how disappointed they were when they cut the wire and made off with it. When they got to the scrap dealer, they found out the scrap dealer didn't want it. So, because they couldn't separate the copper from the steel.
Is there a pattern for which lines are which?
Yeah,
Is it measured from the center post going out?
yeah, there's some standards for that, and hopefully we've got a hook out right now to get a copy of the old L&N signal standards. We've got the CSX signal standards, which have that type of information in it. But if we can find, I've got a couple old signal maintainer buddies that are hopefully going to help me get a good set of drawings for that sort of thing that we'll have in the archives. Okay? There's just a simple relay case involving the circuitry for that system. And of course, your waste, that's a simple, single mast, single set of lights. And here's something that's more complicated. Again, all these arrays of lights are determined, again, by the municipal agency. In most cases, the state DOT. So, and you see this one, they even has a solar panel associated with it. So, okay. Hot box and dragging equipment detectors. This would be your hot box detector, and it's looking for the thermal signal coming from the end of the axle. And comparing it, the circuitry associated with that compares the two temperatures, axle, on the same axle, and also the temperatures on multiple axles in that car. So any certain variation in that will trigger the warning. Dragging equipment detector are just paddles that spring loaded. Sometimes you can even push them with your foot. But those would be like a dragging air hose or piece of component off of a freight car or something. Would hit those paddles and trigger the warning to the crew. Okay? All right? These are just, again, O-scale. The modeler here was a good buddy of mine in the signal department, Eric Peterson. Eric's up at Indianapolis now, but he had a wonderful O-scale layout up there. And so it shows how he's done his wire connections, relay cases, the battery well, and so on. Again, same installations over here. And there's even a door signal for this route coming in, all right? Crossing diamond brings on another set of components that you need if you've modeled a diamond somewhere. And I like the way he modeled a diamond, even though that track doesn't go anywhere. It has its own unique set of details. And Eric, being in the signal department, he modeled a signal crew using a hydraulic system to force the cable over underneath the crack. Okay. In his case, he uses an infrared presence detector on his layout to trigger his warning system. All right. And then here's some examples of various signal types, and this is showing your position light signals that you would find typically on those railroads. Okay. The searchlights, which are my favorite because I guess I was used to them from the L&N side. All right. Again, use of LEDs has really opened up this field electronically, but you can see it involves a lot more than I'm capable of. Okay. And he uses that system that the modeler Bruce Chubb introduced to the model railroad community years ago. I don't think Bruce Chubb is alive anymore, but that's all of the interfaces and everything that Eric uses to operate his signal system on the layout with his a desktop computer. Okay. And this is from out of Greeley, Colorado. I don't know if any of you have ever seen that layout, but if you ever have the chance to be in Greeley, go see that. It's an amazing
Is it the
setup.
Colorado Railroad Model Railroad Museum?
No, it's, that museum is in Golden. This is in Greeley.
Okay.
And it's in like a 150 by 150 building. Even has a caboose inside.
Michelle's.
But this is their TC panel and what their wayside signals look like.
Yeah,
And
this
there's
is
something
way
like
out.
30,000 trees on that layout. It's phenomenal. And open to the public for a small visitation fee. But the Union Pacific tracks are right outside the building,
Yeah, that's,
between Denver and Cheyenne. And when the train hits the circuit for the warning system in downtown Greeley, the signal people have wired that layout up so that if you're in that room, you start getting the lights come on and warn you the train's coming, and then he's got a viewing window, and you can run to the window and watch the real train go by. So you get the full experience. Okay? In fact, there's the inside of it, of the building, just taken from the mezzanine around it. It's amazing. Okay? All right, you can see what my conclusion was. I can just take a bare bones layout and add a little bit of static signal detail to it, and about as fast as adding brake rigging to a quality kit and trying to put all that brake gear underneath the underframe. And there's the advantage of it that I hope this little module demonstrates that you can do for your own layout. And to the degree that these components are available in your scale, then wide open. Okay, a couple more pictures, I think. Just the acknowledgements, and all right, we'll go on. And I've forgotten where that picture was taken, but
That's Sydney, Ohio, eastbound looking, that's the B&O Toledo sub going underneath the Indy line.
wow.
And you can see the connection.
did you take that picture?
No, but I bet Dave did. But yeah,
That's
that's,
probably where I got that. Okay.
So what's the amber lights at the?
that's
upper
the locomotive, that's
Oh, yeah.
going away.
That's it.
Man, they're
Any
getting
questions?
Been there.
That was good.
Okay.
You know, one thing you might, I think for L&N modelers, if you're modeling like a Corbin division, they have these derailment indicator lights up there in the narrows, I think it was,
Yeah.
with LEDs and crossing circuits. Now you could easily have it, because they were, when a train approached, we got in the circuit, they were all in sequence, wired together, and they would flash white. And and they had like a brittle piece of wire laying on top of a piece of wood, and if something dragging, a train derailed and broke the wire, all the lights would go out.
I'm glad you brought that up, Scott, because we had those in 3 locations on the L&N. 2 were on the Corbin division, 1 on Crooked Hill, 1 on Duff Mountain.
Yeah.
Between Morley and Chaska. And the other was on Cowan Mountain, on the former NC. We had the flashing lights up through there, and the concept was a brittle rod, we called it the brittle bar, and all it did was break a battery-powered circuit and cause the lights to quit flashing, and that you knew that you needed to stop.
Yeah, that'd be neat to model the layout now.
And if you go back in the L&N Society magazines, far enough, I'm not going to tell you which issue it is, but I wrote an article about that and how it was invented and what have you, and why it was used on the L&N back during the terrible derailment period of the L&N. But I issued a challenge on there for the first modeler to actually model that on the layout would be entitled to a prize. I never got the first entry. So,
It's easier than ever now, optical detectors and LEDs, that would be something to see.
and I'm not saying what the prize is, but,
So what does
This
the
one's
L&N
probably
do to
surprise.
detect, rock slides up in the mountains?
same thing that all railroads use, a regular slide fence, which would be, usually it was, the stanchions were old rails driven into the ground. And common steel fencing, and the steel fencing was tied to a circuit much like what Scott just described. If the fence got pushed, there was a spring tensioner on the end of all that, but if the fence got pushed far enough, it would activate the circuit and give the signal, give a red signal to the train.
A BN signal maintainer told me about dealing with those up in the Glacier Park area, where sometimes deer would get tangled up in them. They'd have to try to get them out, but he said if you got a moose in one, the moose would rip right through it.
Yeah, I don't doubt that. So, you can model, I could have included that in this presentation, but modeling slide fence, there were a number of locations on, even on CSX today, on all of the predecessor roads of CSX had some cuts and so on where slide fences were in use.
This goes back a little bit further than anything we've heard today. But in the late 50s, I'm riding with my dad. We're following the train tracks out of Irwin on the Clinchfield. And all of a sudden he pulls over, gets out and runs up to the rails to wait for the train engineer to go by. And he's doing one of these numbers. Like that. Gets back in the car and said, Dad, what's going on? He said, they got a hot box throughout the front of the trains. I'm letting them know that they've got one. So I guess it's before they had hot box signals. I don't know. But it's quite exciting for a young man to see his father do something like that.
Still do it today.
Yeah.
If you're a train crewman, have a radio,
Really?
this is, and if it's toward the head end like this, rear end of the train, you hit your rump, and then
He did it across his chest for the front part of the train.
kind of the middle of the train.
Yeah.
That part hadn't changed, and in those days, you didn't have roller bearings typically.
No.
So, if you'd see a hot box, you could sure tell it. And some of the locomotives, even the roller bearings on locomotives, that were some of the first roller bearings in the industry. And they had plugs attached internally in them that were stink bombs. And that's kind of where this came from.
Really?
Is they would melt and smell terrible. And one of the common shop pranks was to get one of the stink bombs and set it off, and everybody goes running in another direction. And, there's another hour's worth of productivity loss. Let's go take a break.
Wow.
So quite an industry, quite an industry.
Okay, I guess that wraps this up. That's the last we had on the schedule.